Today we're going to talk about writing fundamental trig identities and being able to recognize them. And the whole goal of this is to be able to use the identities, evaluate them, simplify them, and rewrite the trig expression. This trig identity reference sheet that we started the other day will be reviewed here as well, so you can pause at that time and fill that paper out if you need to. So the reason that we want to do this is to be able to rewrite trig expressions. If you understand what's happening and how to make it simpler with your trig identities, and it helps it go much quicker. So here's the trig identities reference sheet. We had learned with our foldables on the first day, this reciprocals identities, and then on day 2 we talked about these quotient identities, how tangent and cotangent are really just sine over cosine or cosine over sine. And then you explored with your group and then wrote these Pythagorean identities down. That's all you need to really worry about right now. There are some others on this sheet that we'll see as we go. You're welcome to copy those as well if you want at this point, but it's up to you. All right, so some strategies you need to write in your notebook about how to simplify trig expressions. Substitution is usually the first thing you look at. Is there any way I can substitute something else for a piece that will allow me to eliminate or cross-reduce or something like that? Factoring is a point, but multiplying by 1 is the same thing as multiplicity identity or multiple of identity. Factoring has to happen sometimes, not very often, but it does happen. Rewrite terms over a common denominator. That happens quite a bit where you have to put terms over a common denominator. Split up single fractions into equivalent terms and rewrite so it's not in fractional form. And then never leave a square root symbol or I always want to get rid of the conjugate on the bottom in the denominator. So here are some examples of just substituting. So if I ask you 1 minus sine squared of theta or x, what does that equal? You can use your trig identity sheet and be like, well, 1 minus sine something, that's got something to do with Pythagorean, so let me see what that would equal. And if you go to your little sheet, and they could be rearranged, and that's okay, you will find out that this is the same thing as cosine squared of x. And I'm using x because x was used over here. Now the next one, try to simplify it. The next 2, pause, and then see if you got it right. So here's the answers for the next 2, just using your trig identity sheet and knowing another way to substitute for the same thing. They mean the same thing. Now we're going to talk a little bit about simplifying. So we're going to look at something that's given to us. So cosine of theta times tan of theta is given to us, and we have to write it as a single piece. Simplify as much as we can. So these are actually being multiplied together, so we can look at these as individual things. All right, so we can think cosine is pretty straightforward. It's one of the original identities, so we can leave cosine alone for now. We don't have to rewrite it as secant, 1 over secant, because there's no other secant in there. So we want to try to leave things as simple as possible. But tangent can be rewritten as sine of theta over cosine of theta. And then we can reduce, so these cosines reduce away, and we're left with just sine of theta. So cosine theta times tangent theta reduces down to sine of theta. For a moment, see if you can do it, and then come back, and you'll see the results. Secant of theta can be written as 1 over cosine of theta. Tangent can be written as sine of theta over cosine of theta. And then these are a fraction divided by a fraction. So we're going to set these up in a way that we can hopefully reduce something. So then we multiply by the reciprocal. These cross reduce, and we're left with 1 over sine of theta. And if you use your trig identity sheet, 1 over sine is the same thing as cosecant theta. So that's your answer there. I want you to try C and D, and then you can pause and come back and check. See, we're going to write them as simply as we can. So sine of theta. It's pretty simple. It's kind of our foundational one. Cotangent, however, can be written with sine in it, and it's actually cosine of theta over sine of theta. And then cosine can stay. So now let's think about how to eliminate some of these. We'll just make these look like a fraction for each of them. So we need common denominators. And right now we're adding here, we don't have common denominators. We could simplify by multiplying over here. So we'll go ahead and do that first. So we have sine theta over 1 plus, and we can multiply these. So cosine will give us cosine squared of theta all over sine of theta. Now we need to add these, but we have to have common denominators. So we're going to multiply all of this by the common denominator to get it to sine of theta. And so we multiply this piece and we end up with sine of theta squared. And then here we end up with cosine squared of theta all over sine of theta. Now, let's simplify this. The first top piece, this whole thing here, is one of our Pythagorean identities. This actually equals 1. And 1 over sine of theta. And then we can rewrite that as its reciprocal, and that will equal cosecant of theta. And that is your answer there. Okay, so cosecant we can write as 1 over sine theta. Secant we write as 1 over cosine theta. And then we can multiply these. So we'll keep this one the same and then multiply by its reciprocal. So cosine of theta over 1. The 1's then cancel out, and then we're left with cosine of theta over sine of theta. If we look at our quotient identities, we'll know that this is the same thing as cotangent of theta. All right, try E and see how you do with that one. So for this one, again, we're going to try to write it as simply as we can. Cosine is one of our basics, and cosine is one of our basics, but secant is not. So let's think about how we can rewrite secant. So cosine of theta, this is multiplying. Secant can be written as 1 over cosine of theta, and then minus cosine squared of theta. So when we multiply these, we can cross-reduce, and this is 1 minus cosine squared of theta. And this is a Pythagorean identity, which we know equals sine squared theta. Alright, so you're going to finish working on the 4.2 practice. Look at the key, partial key. You should have ratios set up, and you got to watch your signs because of your restrictions using the All Students Take Calculus method. And then make sure all your work is shown. There's a partial key with answers, and then a couple of the problems have been worked. If you need other ones worked, email me and let me know. And then you'll complete today's activity showing all your process. So you'll see Canvas has got the full amount of things that you're working on. Don't forget about your Rise Above activity as well. So this is a hard copy sheet that you were given. The first part is matching. So you're matching to see what's equivalent, what's equal to each other. So just a workspace down if you need it, but then you can just draw lines to match. And then here you're circling all the expressions that are identities. Watch out for ones that are not rearranged correctly. So you're circling ones that are identities. And then the last part is simplifying identities. You should have your work shown underneath. These are like the samples from the notes.